Okay, the fifth exercise in the fan test stand lab session is to test a single 5 horsepower fan, and I'll show you this new setup. So bear with me as I walk with the camera. There's our new set of flow restrictions, which we'll go over in a minute. Once again, here is the set of static pressure taps where we record delta P, which we'll use for the flow rate calculation Q, our flow restriction box. Here are the pressure taps where we record P sub S, the static pressure developed by the fan, so that's downstream from the restriction box. And then here you can see that we've removed the 10 horsepower fan and we've replaced it with a single 5 horsepower fan. It's got a larger rotor diameter, so we have a conical transition adapter here. This fan doesn't fit in place quite as well as the 10 horsepower fan, so we have to prop it up on some wedges, but that's part and parcel of mining engineering, and it works very effectively. So bear with me while I put the camera back onto the tripod. All right. As for the 10 horsepower fan, we use this laminated sheet here as a guide for the flow restrictions for the single 5 horsepower fan. And you can see that it's a different list. We've got the speed settings up here. The restrictions are, as you might expect, given that this fan has a lower power rating, the restrictions are slightly less restrictive, so to speak. Okay, and here is again a partially filled in data sheet for the case of the single 5 horsepower fan at low speed. You can see that we have the list of restrictions already filled in, and we've got the atmospheric pressure and the dry bulb temperature here for calculating the density. And again, to repeat for all of these tests, the very first case will be open. Okay, these guys going. Okay, I'm going to activate the VFD pendant here, which is already set to the correct setting for the low speed test for the 5 horsepower fan. And while the fan is getting up to operating speed, I want to go over the P versus Q plot again, the fan curve. So once again, here's a generic fan curve that we looked at a few minutes ago. On the horizontal axis will be the flow rate Q, and you're going to calculate that using the delta P measurement that's on the data sheet that we're recording, and then the equation from British Standard 848, which is also on the data sheet handout. You'll also use the air density W, which you will calculate from the barometric pressure and the dry bulb temperature. Then on the vertical axis here is simply the static pressure that the fan generates in response to the restrictions placed in the flow box. And again, this is the column labeled P sub S on the data sheet. And you'll plot this directly on the vertical axis of your plot. No calculations are required for that. So this is your basic fan curve, but it's much more useful if you have electrical power consumption, the aerodynamic fan power, and especially the efficiency plotted as well. So if your spreadsheet program allows you to plot several curves on one graph, that's preferable. And if you're able to do so, then you would have those values on the right-hand vertical axis here, with Q still on the horizontal axis. So please be sure to contact any of us if this is confusing. It's a lot of points to calculate, but at least everything should be conceptually concrete and not too abstract. Okay, it looks like the fan has ramped up to speed, and we can begin taking data. As you can hear, this fan is much quieter than the 10 horsepower fan was. This fan gets up to about 1188 RPM max, whereas the 10 horsepower fan will actually spin up to 4000 RPM. For the low speed fan test here, we are running at about 780 RPM. Okay, so again, with the case of open, no flow restrictions, I just read across my instruments. My delta P is 0.293. My P sub S is 0.317. Again, these are inches of water column. The amperage is 2.41. The voltage is 310 volts. And the power factor is 0.40. Okay, And then I haven't measured the RPM yet. I will do that separately, but it's about 780 RPM. And once again, that remains constant usually throughout the tests. So we fill in our data sheets like that, okay? So that's the first data point, 5 horsepower, single fan, low speed. The first flow restriction I'm going to put in place is M5. Then we pull the top off the box, and because the pressure inside the wind tunnel is lower, atmospheric pressure helps to make a seal there. There is our restriction M5. Put the lid back on. We'll give the flow a minute to equilibrate here. And now we're ready to take our second data point. So delta P has dropped down to 0.274 inches of water. P sub S has increased to 0.361 inches of water. Voltage is still 310. Amperage is still 2.41. And power factor is still 0.40, okay? So that's our second data point. Again, goes pretty quickly. For the third data point, we'll remove the M5 restriction and put the M4 restriction in. Right, here's M4. We'll let the flow equilibrate. Okay, the delta P is now 0.235 inches of water column. P sub S is 0.439. Voltage is still 310 volts. Amperage has gone up a little bit to 2.42 amps. Power factor 0.41. So it's working a little bit harder, not a lot. And just remember from earlier videos that what we find for our fans running here is that when we're not asking a lot of them, when they're just loping along, the electrical power consumption is fairly constant. And so as the aerodynamic power increases due to the restrictions placed in the box, the operating efficiency ramps up a little bit, okay? So once again, as for the 10 horsepower fan, keep replacing the proper restrictions, recording the data. That's it. At the end, I would record the RPM again to be sure that it didn't change, and then go ahead and ramp up the speed to the high speed setting. Again, about 1188 RPM for this fan, and repeat the same readings, okay? I think you get the idea from there, so we'll go ahead and end this segment.